Let's talk about a radical conjugate and why it's useful. And I have three different problems here that are from the homework. So we'll go over each of these in turn. The first is just coming up with, what does this radical conjugate mean? What is the concept even? And what you do is, like with a complex conjugate, if you've seen those before, you simply flip the sign on the radical part. So the radical conjugate of negative 3 plus radical 3 is negative 3 minus radical 3. And likewise, for this next part, the radical conjugate is going to be 8 plus radical 2 instead of 8 minus radical 2. So that's what a radical conjugate is. And here's why it's useful. If you multiply something by its radical conjugate, so in this case, what is 8 plus radical 2 times 8 minus radical 2? Well, if you remember the polynomial identity for difference of squares, remember a plus b times a minus b? What do we get from that? If you remember, this is a squared minus b squared. That's a very special polynomial identity you should always have memorized. Well, what's a and what's b? So let's just figure this out. This is going to be, a squared is going to be 8 squared. And that's going to be minus b squared. B squared is just radical 2 squared. So radical 2 times radical 2, which is just 2. So this is 8 squared minus 2, which is 64 minus 2, so that's going to be 62. Here's what's cool. The radicals are gone. When you multiply something by its radical conjugate, there will be no radicals in the answer. Just like when we were dealing with complex numbers, if you multiply a complex number by its complex conjugate, you wipe out all imaginary terms. So we're going to use that in rationalizing. And remember what rationalizing means. It means multiplying something by a crazy one in order to change the way it looks, not necessarily change its value, just change how it looks. And here's what we don't like about these two fractions right here. These radicals in the bottom, they're not great. Grammatically speaking, they're just a problem for us. So I want to rewrite this fraction as something with no radicals in the bottom, and the way to eliminate radicals is to multiply something by its radical conjugate. So let's go ahead and do it. I need a little more space for this one, so I'm going to take this part right here, and we'll go ahead and write it out down here. 3 minus 4 radical 6 divided by negative 1 minus 5 radical 6. And what's the crazy one we're going to pick? Well, it's going to be the conjugate, which is negative 1 plus 5 radical 6. And negative 1 plus 5 radical 6. Remember, it has to be the same on top and bottom to be a crazy one. And now, what do we get? Well, need a little space here. We'll go in order. So 3 times negative 1. Let me use arrows. 3 times negative 1 is going to be negative 3. And 3 times 5 radical 6 is going to be 15 radical 6. And then we have negative 4 radical 6 times negative 1. So that'll be positive 4 radical 6. And our last one here will be negative 4 radical 6 times 5 radical 6. That'll be negative 20 radical 6. So clearly there's a lot of radicals left on the top. But remember, the top was not a conjugate. It's the bottom that was the conjugate. On the bottom, this is really easy. It's just a squared minus b squared. So a squared is negative 1 squared minus b squared. Well, what's b? That was 5 radical 6 squared. So let's simplify this all down, see what we get. On the top, we have negative 3. And now we have a whole bunch of radical 6s. I'm sorry. Look what I did. Whoop. I made a mistake earlier. Negative 4 times 5 is negative 20, but radical 6 times radical 6 is just 6. So, working this out a little more now that it's correct, this becomes, what do we have here? Negative 3 plus 19 radical 6 minus 120 on top. And on bottom, it's going to be 1 minus, 25 times 6. We square the 5 and we square the radical 6. So we work that down a little more. And we get negative 3 minus 120, that's negative 123 plus 19 radical 6. And on the bottom, that's going to be 1 minus 150, so that's going to be negative 149. So that looks great. That's a much nicer fraction, believe it or not, than what we started with right here. And the reason is, it doesn't have any radicals on the bottom. And for a variety of applications in mathematics, that distinction is important. So you can write it in this form, and that's perfectly correct. You can simplify it a little more if you want, but I think we get the point now.